Hello dear students. So in the previous class we studied the balance condition of the Wheatstone network, and what was the purpose of that derivation is to find the value of the unknown resistance in terms of other three resistance, and we had got the formula that R1 by R2 was equal to R3 by R4. So in order to get this condition, this is a balancing condition, the requirement was the current through the galvanometer should be 0. So to recall few things, I'll just show roughly. We had taken 4 resistance and connected them in this way, and I just simply connected with the battery. I had 4 resistors R1, R2, R3 and R4. So here I have connected with the galvanometer. Let me give a name as A and B at this terminal. So in order to get this formula, the condition or the necessity was the current through the galvanometer would be 0. That is, the potential difference across the two terminals of the galvanometer should be 0. Quite obvious, right? Whenever there is no potential difference, no current will flow. Current will flow only when there is a potential difference. That is, if VA, potential across A, if it is equal to potential across B, then the current would through the galvanometer would be 0. And once the current through the galvanometer would be 0, then this condition would have been satisfied. But whatever this derivation we have done it theoretically. Now today we are going to study a meter bridge. Meter bridge is actually the application of the balanced Wheatstone network. So our today's topic will be meter bridge. So meter bridge is a device. Let's just write. And one more interesting thing of meter bridge is, so today's title is meter bridge. Again, they may ask a question for a 5 marks. Straight away they may ask for 5 marks. No chances of asking for 2 or 3 marks. Probably they may go sometime for the 1 mark, but most probably they may ask for 5 marks. Now meter bridge. Meter bridge is a device which is used to find unknown resistance. So it's a device, and the good thing of the meter bridge is you will be doing this in the practical also. So today try to visualize the thing, imagine the thing, how does it looks actually a meter bridge, and once you do the practical, the things will be quite clear to you. So it's a device which is used to find the unknown resistance, and we know what will be the principle. Obviously it works on the balance condition of the Wheatstone network. So principle involved in meter bridges. So the question they may ask you in this way: what is a meter bridge? Explain its construction and working. Okay, or they may ask you to explain the entire experiment. So you have to write systematically, write the what is meter bridge, what is the principle involved, draw a neat label diagram, then show its construction and working, and get the desired formula, whatever it is required. So it works on principle of balanced Wheatstone network. So quite obvious. So the principle involved in meter bridge, it works on the principle of balanced Wheatstone network. And obviously all of you know key balance condition, what does it demands? It demands 4 kinds of resistance, out of which we must know the value of any 3 resistance. And once we know the value of any 3 resistance, easily I can get the value of the third any unknown resistance. That is the 4th unknown resistance. Fine. So you are expected to write this thing, then only you start the actual practical. So first thing is you should draw a neat labeled diagram. Now any meter bridge would look like, try to imagine. Okay, so any meter bridge would look like this way. This is an wooden block. Imagine it's an wooden block. On that wooden block I have one wire. Basically a wire should be an alloy of consonant or else magnesium Magnean, this would work. And the wire should be such of, it should be of uniform cross sectional area. There should be not be an variation in the area at every point. A wire of length 1 meter or 100 centimeter. Okay, there's a cardboard, there's a wooden block, not a cardboard block. There's a wooden block. On that wooden block, I have taken a thick wire of uniform cross sectional area, basically an alloy, maybe constant or Magnian, of length 1 meter or 100 centimeter. Okay, try to imagine the things. Now, the alloy or the wire should be such that the resistance of wire should be independent of temperature. Independent of temperature. There is nothing called like an ideal wire which will totally not depend upon the resistance. Almost all the conductors are temperature dependent, but we must select such an alloy key it should be least dependent on the temperature. So please make sure ki whatever kind of wire you are selecting or alloy you are selecting, it should see ki it should least depend upon the temperature. This is the condition. Now on this wooden block I have one scale installed to it. Scale, okay, having reading like 1, 2, 3 and so on. There is a scale in centimeters. So I may get 97, 98 and 100 centimeter. Okay, can you imagine the things? Yes. So let me erase this. Remember the things. A wooden block. On that wooden block there is a wire of an alloy, Magnian or constant, attached a scale to it. Now this wire, this wooden block is connected with two L kind of L-shaped metallic plates. L-shaped metallic plates. Okay, so basically this would be a copper or maybe a silver. Okay, so you should take these two kinds of metal plates. Okay, L-shaped. Two you should take. One I will connect it from here. I hope it is synchronizing. Fine. Okay. So I have taken two L-shaped metallic plates. L-shaped metallic plates. Okay. Basically, it would be a copper or it could be a silver also. And on that, there at the center, I will connect with one more, a rectangular type of metallic plate of same material. Now the interesting thing here is this metallic plates would have a terminals. Okay, it will have totally 5 terminals, 1, 2, 1 at the center and the other 2 here. So first 2, last 2 and at the center. Now the main purpose of this meter bridge is to find the value of unknown resistance. So whatever unknown resistance we are taking, we are going to connect it here. I would connect it here, and this I would give a name as R, where R is unknown resistance, whose resistance is to be found out. You take any wire, copper wire or any metallic strip, and you just connect it and you try to find the value of this unknown resistance. Now the main thing here is the galvanometer, because galvanometer is going to decide the balancing condition. Once the potential difference across the galvanometer is 0, galvanometer will show a 0 deflection. I hope everybody have seen galvanometer. It has 0 pointing at the center, and on the either side it has deflection, 30 divisions here on left hand side and 30 divisions on the right hand side. Now at the center I am going to connect with an galvanometer, and the another end of the galvanometer is connected with a sliding contact, or it is also known as a jockey. Okay, so sliding contact is just like it's a wire having a knife like edge. Okay, and it is free to move across this wire. It is basically like a tester. Okay, tester, you know, right? Tester you take and you just plug into the switchboard. So you just see key to confirm whether the current is flowing or no. So it's just like same thing, sliding contact, or we call it as a jockey. So middle terminal and the last 2 terminals are connected with the standard resistance, S, standard resistance, or you would call it as known resistance whose value we know. So basically we take a resistance box which has a particular switch on it, and as per our requirement, as per our desired value, we can just plug in and give the unknown resistance, the known resistance. So we know the value of this S. So let this terminal be A, let this terminal be C, and let this terminal be B. So now what I will do is, from these terminals I will connect with the battery, and battery is provided with the plug key. Plug key acts like a switch, it's a plug key, and this is the battery, plus minus, so current is flowing in this direction. And now what you are going to, our main aim is to find the value of this unknown resistance. So this is the circuit diagram. So our main purpose is to find the value of this unknown resistance. How we are going to do this? You know a gallon meter. What does a gallon meter does? Gallon meter is a device which is going to detect the current. For instance, you can imagine gallon meter look like this. It has the pointer pointing 0, and on the left hand side we have 30 divisions, on the right hand side also we have 30 divisions. So this pointer is free to move once if it is connected to the any electrical circuit. So if there is current flowing through the gallon meter deflects. It may deflect on the left hand side or it may deflect on the right hand side. The deflection indicates ki the current is flowing through the circuit. And if it is not deflecting, then if it is pointing towards 0 means it is as good as saying ki there is no current flowing through the circuit. In simple, I would say ki there is no potential difference across the circuit. So it is free to move across other ends of the deflection. So this is the gallon meter. Now once you turn on the battery, once you allow the current to flow, what is under your control is the sliding contact. You are going to take a jockey and you are going to place it here. What you will observe here is, you can again imagine a gallon meter. This is the pointer, this is the 0, this is the 30 divisions here, this is 30 division, 20 here and 10 here, 10 here and 20, 30. Once I place my jockey here, I find ki my gallon meter has deflected here. Once again if I lift it and I bring it here, my gallon meter has deflected here. What it is indicating? It is indicating ki there is current flowing through this circuit. But I am not interested in the deflection of the gallon meter. I want such a point on this wire where the gallon meter should neither deflect here nor it should deflect here, but it should come to the 0. And once it comes to the 0, it is quite understood ki balancing condition is satisfied. So what I will do here is, now use your common sense. Once I place it here, it is deflecting that side. Once I keep it here, it is deflecting on this side. So it has been understood ki if I slowly take this sliding contact over this wire, you would find ki this gallon meter would slowly come here at the center, and at one particular length of the wire, I have told you the wire is of 1 meter, okay, or 100 centimeter. At one particular length of the wire, you would find ki the galvanometer has pointed towards the 0, indicating ki no current is flowing through the galvanometer, and you are going to mark that point. So for instance, I have marked the point C. What C indicates? C indicates the balancing point, or in technical terms I would call it as a null point. Null point is that particular point on a meter bridge wire where the galvanometer reading is shown 0. Galvanometer reading is shown 0. That is called as a null point. Okay, so at this point the balancing condition is satisfied. Are you understanding, student? So if this is the length, this wire is of 1 meter. So if this is the distance L, what would be this distance? Wire of 1 meter, this will be 1 minus L. Yes or no, students? So if this is the distance L, the remaining distance will be 1 minus L. Yes or no, students? Because the condition here is I should require a 4 resistance. When I look at my diagram, I have only 3 resistors. R1, the names are different, R, S and a wire itself. Wire itself acts like a resistance. But where is that fourth resistance? So with the help of sliding contact, I have indirectly divided the wire into two parts. Wire with this section and wire with this section. So now you can consider this as R1, this as R2, this part of wire is R3 and this part of wire is R4. And now I can apply the Wheatstone network formula. Now you would tell ki R3 and R4 would be definitely different. You cannot argue ki this is of same wire, so same resistance will be there. No. If you remember, the resistance depends upon the length as well as the cross-sectional area. So this R3 is not equal to R4. Just remember this length L. L is the balancing point and the remaining length will be 1 minus L. So have you understood how it works? Now we'll do little bit of mathematics and we'll derive one equation. Clear? Have you understood? I'll just recall few things. There is, imagine there is a wooden block. On that wooden block there is a thick wire, basically an alloy. Make sure it should be independent of the temperature. A length of 1 meter. On that wire itself, just below the wire, I have placed one scale just for the measurement to get that distance L. Now I can tell no what is L here. Yes or no? Now on that there are plates. On that plates there are terminals. Okay. This is actually the 2D vision. Okay, 2D diagram. उसपे ही plates होते हैं and that plates have terminals so that I can easily connect with the help of wire. Now connect end A with battery positive, end B with plug key and battery negative. Allow the current to flow. Once you place galvanometer here, deflection. Once you place a sliding contact here, galvanometer deflect here. Once you place it here, galvanometer will deflect here. So somewhere in the middle it has gone through that zero, so only it has come here. So find that balancing point with patience and you will get that point C. That C point is the null point where galvanometer shows zero deflection. So measure this distance length L. The remaining distance will be 1 minus L. Are you understanding? Yes. Now I have 4 conductors here or 4 resistors R1, R2. That is R and S. I will not go with R1 and R2. R, S, AC and BC. AC and BC. Okay. So remember AC and BC. So construction and working you should able to write. Now from Wheatstone network, can I write R by S equals to resistance of AC divided by resistance of BC? Yes. And you know ki resistance R equals to rho L by A. All of you should know this thing. Maybe in the third lecture you might have studied. Maybe a second lecture I would see. Resistance is rho L by A. So for AC, it is rho L by A. And for BC, it is what? Rho 1 minus L by A. Yes or no? AC was L. The remaining part was 1 minus L. So this much length is been reduced. So obviously there would be change in resistance. So here what it would be? R by S equals to resistance of AC is what? Rho L by A. Similarly, I will write it here. Rho L by A. Resistance of BC is what? Rho 1 minus L by A. So from this diagram, I can cut rho with rho, A with A. And what I am left here is L divided by, I'll write small l, L divided by 1 minus L. So what you get here is R by S equals to L by 1 minus L. So your aim is to find this unknown resistance. So R will be what? SL divided by 1 minus L. So if I know the length where the galvanometer shows a zero deflection, I can easily tell you what is the value of the unknown resistance. This S is under your control. You are going to decide how much resistance you are going to put. This is S is the standard resistance, or you would call it as a known resistance. It's totally in your hand how much you are going to put. As per that, the balancing length will vary. So this is quite simple experiment, you'll be quite lucky enough if you get this experiment in the exams also, in the practical exams. Easily you'll score 30 out of 30 marks. Quite easy experiment and very easy to understand if you know the balancing condition. So this is all about today's class. So we'll meet in the next class where we are going to study the potentiometer, again one of the practical part itself. So that will conclude your current electricity topic. So that will begin with the new chapter, that is moving charges and magnetism. So till then, thank you.